Hello everyone. Today we'll discuss how to find domain and range of a rational function. Okay, so let's just talk about it. So let's just talk about domain and range for real quick. The domain. What is domain? Domain is if you have a function, all the input. Let's say you have a function like this, right? This is like f of x. So all the input is your domain, and all the output is your range. Okay. Now let's get to rational function. So rational function we can write down as a form of this f of x equal a of x divided by b of x. So here a of x and b of x are polynomial, two polynomial function, okay? Polynomial function. But here the condition is b of x cannot be 0. No matter what, b of x cannot be 0. What does it tell us? It does tell us the domain of this function cannot be here, the denominator cannot be 0. So that's mean, let's say if you have this function, the domain will be the denominator we have, it cannot be 0. So if we solve it, then we can solve for x, that will be our domain. Okay, so let's do a practice. Let's look at this rational function here. Here denominator cannot be 0, right, for the domain. So x cannot be 0, so you can just write down x all the real number and x cannot be 0, right? That's our domain. And for the range, since x cannot be 0 here, this means here y cannot be 0 either. So y cannot be 0 and y is all the real number. Okay, the reason, so that's our gonna be our range. Okay, so now let's do another practice here. Here you see in this function we can cancel out x plus 8 and x plus 8 here, right? So that will give us just f of x equal x plus 3, which is a linear function. In the linear function, our domain is what? From negative infinity to positive infinity. That's mean, let me just write it down. Domain is what? X, all the real number, and x, right? And range is also y is all the real number. Okay, but in this situation it's not gonna be in the case, okay? Because when you graph it, you'll see there is a hole on here at 8. There will be a hole on x equal 8 when x is 8. Okay, so that's mean domain is still in the fraction, domain cannot be 0. That's mean x plus 8 cannot be 0. That's mean your domain is just x cannot be negative 8. So your domain, you can write it down, your domain is x all the real number and x cannot be negative 8. And for the range, you have since it cannot be negative 8, right? So now you can just put it in the function f of x. You can just put since once you factor out, you get x plus 3, so you can just put it negative 8 here, which is negative 8 in terms of x plus 3. What you get? We get negative 5, right? So it cannot be this, it cannot be this. Okay, negative 8. Let me just do it. So when you plug in negative 8, since x cannot be negative 8, so you can just write it down, it cannot be negative 8. So it's going to be negative 5. So your range is basically going to be y all the real number, but y cannot be negative 5. That's your range. Now let's I want you guys to know about the vertical asymptote and horizontal asymptote. Okay. Good. Now let's talk about this function, right? Here you can see the numerator and denominator has the same degree. Okay, the x has 1 degree here, x has 1 degree. That's been all, both of them have the same power. Once you have the same power, the vertical asymptote is just, it cannot, this is equal 0, right? Denominator equal 0, which is bx plus m equal 0, which is x equal negative phi negative m by b, right? That's been this is our vertical asymptotes. But horizontal asymptotes is just the coefficient of these same degree functions, right? uh, and their fractions. So here in the numerator you have a, denominator you have b, so it's going to be just a over b. That's all. So now when we see in a fraction, when we see in rational function, when we can find out vertical asymptote and horizontal asymptotes, then we can just do, we can just write it down. That is our domain of the function. So this function, the domain will be all the x, all the real number, and x, all the real number, and x cannot be, okay, x cannot be the vertical asymptote. So what we have, negative m by b. Same thing for horizontal asymptote. For the range is going to be the horizontal asymptote. Okay, so y is all the real number, right, except what, except y cannot be a over b. So let's do some practice that will clear up things, guys. Here you see you have the same degree. So now we can just find out the vertical asymptotes. What is our vertical asymptotes? Vertical asymptotes here is gonna be 8x minus plus 5. So let me just erase this one, so it will be, instead of this, right, vertical 8x plus 5 equal 0, right? So that's mean we can just solve it. X equal negative 5 by 8. Then horizontal asymptote we can just find out here, 3 by 8. Do you see, guys? 3 by 8. So 3 by 8. It's so easy. All you have to look at this and you find out that. So what does it mean here, the domain? So domains mean here gonna be x, all the real number, and x cannot be here, whatever the value of vertical asymptote, 5 by 8. And for the range, we have to find out y is all the real number, and we already find out the horizontal asymptotes, which is 3 by 8. So y cannot be 3 by 8. It is always true for this type of function. Okay, how about this when we have it? You see that? So in this situation, vertical asymptote always the same. In the whatever denominator cannot be 0. So that's mean ax plus b cannot be, for the vertical asymptote is 0. So that's mean it's gonna be x equal negative b by a. That's our horizontal vertical asymptotes. And the horizontal asymptotes, where is that? It's gonna be just this, c. So y equals c. So what's the domain? Domain is x, all the real number here, but x cannot be negative b over a. Since our value of vertical asymptotes is negative b over a, and the range, same thing, x, all the real, sorry, here gonna be y, right? My bad. So y, all the real number, but y cannot be c. So let's do this practice that will clear up things here. So what's the vertical asymptotes here? Is 5x plus 9. I'm going to just write it down for you guys. 0. That's mean x is negative 8 by 5. Okay. And horizontal asymptotes, whatever we have here is a c. So y equal just 9. If you look at this, c, 9 is just like c. Okay. So what will be our domain? X, all the real number, but x cannot be negative 8 over 5. What is the range? Range is y, all the real number, but y cannot be 9. Now, if you think, look at this. It's very easy when we find out vertical and horizontal asymptotes, right? Like this one. Let's go back to this one, right? Look, what's the vertical asymptotes here for this function? Vertical asymptotes is x equal 0, right? Just since x equals 0, nothing there. And horizontal asymptotes is also y equal 0. This means our domain will be here. Domain is x, all the real number, and x cannot be our vertical asymptotes, the value of the vertical asymptotes. So x cannot be 0. Y, all the real number, and y cannot be or vertical asymptotes, horizontal asymptotes. That's mean y cannot be all the real number, but y cannot be 0. Same thing. So if you ask me what will be this, then f of x equal 1 into x plus 1. Same thing. What's the vertical asymptotes here? Vertical asymptotes is what? It is x is negative 1. Horizontal asymptotes is y equal 0. So our domain will be x, all the real number, except x cannot be negative 1. Range will be the same thing. Y is all the real number, except y cannot be 0. Since our horizontal asymptotes is y equal 0.